Relationship related to complementary angle. Before that, I'm giving you one problem. Last class, I derived you two different relations. First is gt square is equals to 2 times r tan theta is equals to 8 times h, where t is time of flight, r is range, and h is maximum height attained by the body. And one more relation related to equation of trajectory, that is x tan theta 1 minus x over r. I derived this part. Nabila?
You derive the first one, sir, not the second one.
Okay. Suppose we have range is equals to u squared times sine 2 theta divided by gravity. So you may expand this relation as u squared 2 times sine theta cos theta divided by gravity. And if we take a reciprocal of it, it will be g divided by u squared 2 times sine theta into cos theta. Similarly, using this, we may relate equation of trajectory as we have y is equals to x tan theta minus g divided by 2 times of u square cos square theta times x squared. This was the equation of trajectory in terms of angular projectile. So we may write this expression as x tan theta minus g divided by 2 times u squared times sine theta cos theta whole multiplied by sine theta divided by cos theta times x squared. Just see in this part, we had only cos square theta in this term, but I have to somehow write sine theta in place of it or adjacent to it so that this whole term would be nothing but reciprocal of range. Since I have just multiplied this sine theta in denominator, so to compensate that, we have to multiply in this numerator as well, so that this and this will cancel out. So we'll get same fraction as it is. Is it clear?
Yes, sir.
So on further, we can write this is x tan theta, and this whole term is nothing but 1 over range times tan theta x squared. So we may take out common as x tan theta from both these two terms. So you're left with x tan theta bracket 1 minus x over r is equals to y. That is equation of trajectory. So this is the relation between equation of trajectory in related with range. Is it clear? Okay, just write it down till this part. You all have written?
Yes, sir.
Now, how to related to any problem these equations? Suppose you have y is equals to x minus x square over 10. So using this, find first angle of projection, second range, time of flight, and maximum height attained by the body. So I'm defining first how to approach this problem. Try to rearrange equation of trajectory in terms of what we had derived like this. So you may write this expression as y is equals to x taken as common from both these two terms. So you're left with 1 minus x over 10. We may write the coefficient of x outside as 1. So if you relate this equation to the above, what we had derived, y is equals to x times tan theta, bracket 1 minus x over r. So try to relate in these two expressions. Since in this first part, we have 1 times x as coefficient. So in this part, we have x tan theta as coefficient. So these two terms must be equal. So on equating them, we can say tan theta equals to 1. Is it clear?
Yes, sir.
So if tan theta equals to 1, so theta will be 45 degree, which is angular projection of that particular particle. Next, if you relate this bracket to this bracket, so on comparing them, you will say range will be equals to 10 meters. Is it clear? Since in this bracket we have 1 minus x over 10, and in right hand side we have 1 minus x over r. So on comparing them, you can say r will be equals to 10. Is it clear?
Yes, sir.
Nabila, any doubt?
No, sir.
Okay. Now we have both theta as well as range. So relate these two terms to find time period, time of flight, and maximum height attained by the body using the above relation. Using this part. You have range as well as tan theta. So if you relate first these two terms, as we have the value of gravity as 10, so you can find t squared from this part. Similarly, if you relate last two terms, you will get maximum height attained by the body. Akash, is it clear?
Sir, not very clear, sir. But
You have to simply apply those equations to find them. Okay,
okay, sir.
try to solve. Relate first and second, you will get value for time period. Second and third, you will get maximum height attained by the body. Try to find. Sham, just check your calculation
Okay, sir.
for the second part for getting height. Mazia, check your calculation. Good, Raza. Good, Nabila. If you relate first and second term, G is 10, G square equals to 2 times R, which is 10, tan 45 is 1. So this 10 and this 10 will cancel out. So time of flight would be √2 seconds. Similarly, if you relate second and third part, 2 times R, which is 10, tan 45, 1 equals to 8 times H. So H will be 20 divided by 8. So it will be 2.5 meters. Is it clear?
Yes, sir.
Akash, any doubt?
No, sir.
Now, next is to define relationship for complementary angle. Let's say time period or time of flight is 2 times of u sine theta divided by gravity. Range is equals to u square sine 2 theta divided by gravity, and h is equals to u square sine square theta divided by 2 times of gravity. So we have to find first what would be the maximum condition or value of theta to get maximum of these terms. So if you put theta equals to 90 degree in this first part, sine 90 will be maximum, that is 1. So time of flight will be maximum 2 times of u divided by gravity. Similarly, to get maximum range, theta will be 45 degree. 45 into 2, it will become 90, and sine 90 will be maximum. So range maximum will be u square divided by g. Similarly, in third part, if you put theta to be 90 degree, sine 90 will become 1, which is maximum. So h max equals to u square by 2g. Now, if you relate these two terms, you will say R max is twice of H max. Is it clear? So these are some relationship to get maximum value of individual term: time of flight, range, and height. Just write it down. Okay, I'm giving you a 5-minute break to all of you. Okay.
Sir, I have a doubt how it's R max equals to H max.
I defined if you put theta to be 45 degree, these two terms will become 2 into 45, that will be 90 degree, and sine of 90 degree will be maximum, that is 1. So
Yes.
this whole term will become 1. So what you're left with, r is equals to u square over g.
Yes.
So this will be the maximum value of range. Similarly, if you put theta to be 90 degree in this part, this whole term would become 1 as sine 90 is 1. So what you left with, h is equals to u square over 2 times of g.
Yes.
So this is called h maximum. Now, if you relate these two terms, just divide these two terms, you will get this much.
Okay.
Range maximum is twice of height maximum. So you'll be asked like this, if a boy can throw maximum to 50-meter height, so what would the maximum horizontal distance he would throw? So it would be twice of that. That would be 100 meters.
Yes. Thank you.
I have given 5-minute break for namaz, I think. Akash, we are doing projectile motion for angular part. Okay.
Okay, sir.
Khalid, are you there? In this part, suppose a body is projected from this point at some angle theta, it will move along this path. So at this point, if you project a body at some initial velocity u, at some inclination theta, so it will attain maximum of this height. So this is called height attained by the body. This total horizontal distance from point of projection till it hitting back to the ground is termed as range. And total duration of time from point of projection till it hit back to the ground again is termed as time of flight. So I have just defined you 3 different formula related to these 3 respective terms. Okay.
Okay, sir.
Okay. Now we have to define for sub complementary angle. So first, what do you mean by complementary angle? If two angles which sum up to 90 degree, so either of them is termed as complementary of one another. Suppose one of the angle is theta and the other is 90 minus theta. So these two angles sum up to 90 degree. So you can say these two are complementary of each other. On the basis of these two angles, we have to define relationship for time, height, range. First, for time of flight, t is equals to 2 times of u sine theta divided by gravity. If you put the value of theta to be theta first, you will get 2 times of u sine theta divided by gravity as equation first. And if you put theta to be 90 minus theta, it will be 2 times of u sine 90 minus theta divided by gravity. Sine of 90 minus theta will be cos theta. So it will be 2 times of u cos theta divided by gravity is equals to T2. So this will be your second equation. Now, if you divide these two terms, T1 over T2, you will get sine theta divided by cos theta. That will be tan theta. So this is first relation between time of flight for complementary angle. Next is, if you multiply these two terms, T1 into T2, it will be 2 times of u sine theta divided by gravity for the first part and 2 times of u cos theta divided by gravity for second part. If you rearrange it, you will get 2 divided by g if we take out as common, and u square 2 times sine theta cos theta divided by gravity. This whole term is nothing but range. So we may write it as 2 divided by gravity range is equals to T1 into T2. So this is another relation for time of flight and range. You may be asked to define what would be the relation between product of time of flight for two complementary angle related to range. So it will be T1 into T2 equals to 2 times range divided by gravity. Is it clear?
Yes.
Okay, first write it down till this part. You all have written?
1 minute. Done, sir.
Next is to define related to height as height equals to u squared sine square theta divided by 2 times gravity. So if you put one of angle is theta and the other is 90 minus theta. So h1 will be u squared sine square theta divided by 2 times gravity, and h2 will be u squared sine 90 minus theta whole square divided by gravity. Sine 90 minus theta is cos theta, so you will get u squared cos square theta divided by 2 times gravity. Now, if you divide these two terms, you will get h1 over h2. In h1, we have sine square theta, and in h2, we have cos square theta. So on dividing, you will get tan square theta as their ratio. Similarly, if you add them, h1 plus h2, u squared divided by 2 times of gravity taken as common from both these two terms. So you will left with sine square theta plus cos square theta, which equals to 1. So you will get u squared divided by 2 times of gravity, which is nothing but height maximum, which we had derived earlier. So this is second relation. We may define in terms of range as if you multiply these two terms, you will get u squared sine square theta divided by 2 times of gravity for first part, u square cos square theta divided by 2 times of gravity for second part. If you multiply this whole term by 4 and divide it by 4, you will get 4 u squared whole square sine square theta cos square theta divided by 16 times g squared. We may rearrange this equation as 1 by 16 u squared. In numerator, we have 4, which is square of 2. So we may write it as 2 times sine theta cos theta divided by gravity and whole square of it. Is it clear?
Sir, 2 into 2 is 4, right? How you got 16?
I have just multiplied numerator and denominator by 4. In denominator, we have already 4. So 4 and 4 will become 16. Okay. I have just rearranged this numerator part. Since we have u square, so we can take u square whole square. sine square, cos square, and g square. So if you take out square from all these terms, you are left with u square 2 sine theta cos theta divided by gravity whole square.
Yes, sir.
Now this whole term in bracket is nothing but range. So we may write it as range square divided by 16 is product of height for two complementary angles. Or you may write range is equals to 4 times root of h1 into h2. Nabila, is it clear?
Yes, sir.
Okay, just write it down. These are some relationship related to this whole projectile, which may be asked in objective exam. You all have written?
Just a second. Done, sir.
Similarly, if you may define for range, R is equals to u square sine of 2 theta divided by gravity. So if you put first u square 2 times theta divided by gravity, first equation, R2 is equals to u square sine 2 theta, which is 90 minus theta divided by gravity. So if you multiply this 2 with this part as well as this part, you will get u square sine 180 degree minus 2 theta divided by gravity. Sine of 180 minus theta will be sine theta as well. And in second quadrant, sine theta is positive. So we'll say it will be sine of 2 theta divided by gravity is equals to R2. Now, if you relate these two terms or equation first, equation second, you will say these two terms are equal. So on taking ratio, it will be 1:1. So just remember, for complementary angle, range of particle will be always equal. Is it clear?
Sir, 180 sine 180.
Sine of 180 degree minus theta. So 180 degree defines you horizontal line,
Yes.
and on horizontal line, there will be no change in that particular function. So it will be remain sine and this theta. Now this whole angle would be in second quadrant, in which sine theta will be positive. That's why it will be plus sine theta.
Okay.
Now, if you further try to find using two complementary angle as 45 degree plus theta and 45 degree minus theta. If you add these two terms, you'll get 90 as well. So you can write, or we can say these two angles are also complementary of each other. Now we have to find range related to these two angles. R1 equals to u square sine 2 theta, in which theta is 45 plus theta divided by gravity. So if you multiply this to this part and this to this part, you will get u square sine 90 plus theta divided by gravity. This 90 will define you vertical line on which sine will changes to cos, and since it is 90 plus theta, so that will be in second quadrant where sine theta is positive. So it will be u square cos 2 theta divided by gravity as R1. So let's say this is equation first. Similarly, if you put the second term, so R2 will be u square sine 2 times theta, which is 45 minus theta, divided by gravity. So this will multiply with this as well as this. So it will be u square sine 90 minus 2 theta divided by gravity. This 90 will define your vertical line on which sine will change into cos, and this whole angle would lie in first quadrant where all trigonometric term will be in positive. So it will be u square cos 2 theta divided by gravity is equals to R2. So again, if you relate these two equations, you will say R1 equals to R2, or ratio of R1, R2 will be just 1. So for any complementary angle, range of particle will be always equal. Mazia, is it clear?
Yes, sir.
Okay, just write it down. You all have written till this part?
Sir, 1 minute. Done, sir.
It's sharp.
1 minute, sir. 1 minute.